All right, guys, so we are back from the interruption. So continue working on part D of this question. And when you're through, just raise your hand and give me the answer that you get. All right, guys. Anybody? Anybody finish part D as yet? All right, let me just write the function, the inverse function. So we have f inverse of x based on what we got a while ago. What was that? What was it that we got? Anybody remember? Can somebody give me the function? Is anyone hearing me? Miss Waysom, do you have the function?
Sir, negative 2x minus 5 over x minus 3.
Negative 2x minus 5 over go ahead, Miss Green, over what?
X minus 3.
All right, x minus 3. All right, so what you're working out, you're working out the inverse of f inverse of 2. So all you're going to do is substitute the value of 2 in the function. So it will be negative 2 brackets 2 minus 5 over 2 minus 3. All right, so when you work that out, tell me what you get. Anybody with the answer? That shouldn't be taking you so much time, you know, guys.
There are -4 minus 5 over negative.
All right, so let us simplify the numerator. So we have -2 times 2 give you -4. -5 over, if you have a +2 and a -3, that becomes -1. Now the numerator, you add them the negative values together and keep the sign as negative. So that becomes -9 over -1. And so negative divided by negative give you +9. All right, so that should be the answer. Let me see the answer, those who got that as your answer for F inverse of 2. Okay, good. Anybody else? All right, so is everybody clear with this now, guys? Raise your hand if you're clear, because I'm going to be moving on. I'm really not getting any response from many of you guys, only Miss Green that I'm hearing so far. I don't know what's happening to the rest. All right, so moving on. So if we substitute what we have here, so this would have given you the solution for the part A, part B, then part C, and so we would get that to be the answer. Now you may be wondering why it is that this inverse function has +2, +5 over 3 minus x. Now this would be depending on the side that you choose to make the subject on, right? So if you make the subject on one side as opposed to the other side, the inverse function can look different, but your answer will work out to be the same. All right? So it doesn't matter if it is different once you're getting the same answer. All right, next. Working out, well, all right, this would be an example relating to inverse function. So for this example, we are saying that you have to find the inverse of the function f of x equal to 4x plus 5 over x plus 2 and use it to solve the equation 4x plus 5 over x plus 2 equals 3. Now, so this is a case where we are using the inverse to solve the function. Now, anybody have any idea why we are able to do this? Why is it that you think we can find the inverse of a function and use that inverse function to solve? Now, if you remember what the inverse function does, the inverse function takes the y value and give you back the x values. So this equation equates to a y value, and the y value is 3. So if we get the inverse function of f of x, we can just put in this value 3 in the function. So this would be the y value. And the inverse function would calculate and give us back our x values. So that's the idea behind it. All right, so I hope everybody understands what we're doing here. All right, so before using the inverse function to solve this equation, I'm just going to ask you to just find the inverse of this function, f of x equal to 4x plus 5 over x plus 2. So I'm going to give you about 5 minutes to do that. Raise your hand when you're finished. All right, guys? All right, so you may begin. All right, did anybody come up with an answer for this one? All right, who is going to walk me through this process to find the inverse function? Ms. Green, you want to walk us through the process?
No, sir.
Ms. Gleason, would you like to walk us through the process? Not sure what is happening with Miss Wilson. Mr. Lamar, would you like to walk us through the process?
No, sir. Sir, and did you hear that CSEC get pushed back 3 weeks?
I didn't hear that.
Sure, what that's the case.
Hold on there, guys. What was the question, Mr. Lamar?
Oh no, sir. I said I didn't want to do it, and I asked if you heard that CSEC got pushed back 3 weeks.
Oh no, I didn't hear that.
Yes, it was.
Well, that would be a lot better for you guys. Now, it is not surprising to me, because remember, I was telling you guys that usually the exam would come a little later down in May. So it was quite surprising that they would have it on the 11th. So because of the changes with all the ups and downs with COVID from the other day, the protocol would have been a bit unpredictable, how they would go about treating with this year exam. And remembering that this year is another year that many students were displaced because of the online program. Many persons have access to online classes, and so some persons will have been set back. So it's not surprising that they actually push it back. All right, guys. So what it means though, it's more practice time for you. So it means that you can make the best use of that, all right? So hopefully I will be able to extend some more practice time with you guys and probably cover satisfactorily most of the topics, all right? All right, so nobody want to volunteer to walk me through this one?
So again, that you did the outline of how I did mine.
I'm not hearing you, Dorothy.
Sorry, my voice was up. I can walk you through one based on what I did.
All right, so tell me what you did, Dorothy.
Sir, I interchanged X and Y. And I have
You're kind of skipping out the steps. So the first step should be you replace f of x with y. You have to follow the steps in a Dorothy, because if you don't do that, you lose marks. So the first step is to replace f of x with y. So you'll get y equal to 4x plus 5 over
Y plus 2.
over x plus 2. So that's the first step, right, Dorothy?
Yes, sir.
All right, so the next step now is where you interchange. So wherever you have x, you replace it with y, and where you have the y, you replace it with x. So now we will have x equal to 4y plus 5. And then now that would be over y.
Plus 2.
All right. And then next.
So I put the X outside, so I put Y plus 2 in bracket.
All right, so you cross multiply. Denominator on the right hand side, you multiply with the x, but as you mentioned, keep the y plus 2 in brackets. So you would have x on the outside, and then you have y plus 2 in brackets. And that would be equal to what we have in the numerator on the right hand side.
4Y.
So we would have 4y plus 5. All right, now once we get it here, our aim is really to get the y's together, because one y is on the right hand side, one y is on the left hand side. So first we want to expand the bracket on the left-hand side, multiplying out by x. So we'll get xy plus 2x
Equal 4y.
and that would equal to 4y plus 5. All right, so our next step now is to bring all the y's on one side and all the x's on the other. Well, put it this way, we bring all the y's on one side. So if we bring these y's on the left-hand side, so this 2x will go on the right-hand side. 4y will come on the left-hand side. So remember now, once you move across the equal sign, you change the sign of the terms. So on the left-hand side, we have x, xy, minus 4y. And on the right-hand side, we'll have minus 2x
Plus 5.
plus 5. Right. And on the left-hand side now, we can now factorize by the common factor, y. So take out y as our common factor. So we say y into xy give you x. Y into minus 4y will just give you minus 4. And then we equate back that to the right-hand side, which is minus 2x plus 5. All right, so our next step now is to divide both sides by the brackets. We divide the left side by x minus 4 divide the other side also by
X minus 4.
minus 4. Now you don't really have to keep it in brackets in the denominator because there's nothing outside. All right, so the left-hand side, the brackets will cancel. And so y will remain. So y would be equal to
Minus 2x plus 5.
minus 2x plus 5 all
Over
over
x minus 2.
x minus 4. Now, so now we can replace this last y here with f of x inverse. So f of x inverse. So therefore, f of x inverse is equal to and so we will have minus 2x
Plus 5.
plus 5
Over x minus 4.
all over
X minus
x minus 4. All right, so that would have been the function of f inverse of x. So that's the inverse function. All right, so our next step now would be to use this inverse function to solve for x for this equation that we have here. Now, as I said, for this equation, on the right side, we have a value for y, right? So the right side is a y value. This 3 is a y value. But remember your inverse function takes the output of the y value and you plug it in the function where x is, and whatever you get when you calculate will be the solution to x. So solving the equation all right, so to solve for x, we would just simplify f inverse of the y value, which is 3. So f inverse of 3, wherever the x is on the right-hand side in the inverse function, we're going to replace it with 3. So we'll have minus 2 times 3 plus 5 all over 3 minus 4. And then now we do the calculation. So we multiply negative 2 times 3, we get negative 6. And so we have negative 6 plus 5 in the numerator. Now, if we simplify the denominator, we have negative 4, positive 3. Now you owe 4 and you only have 3, so you pay back the 3, so you're still owing 1. So you have negative 1 in the denominator. Now the numerator, you owe 6 and you have 5. You pay back 5 and you still owe 1. So it's negative 1 in the numerator over negative 1 in the denominator. And that works out to be positive 1. All right, so therefore, the solution for x so the solution for x is positive 1. So therefore, x equal to 1. All right. Any question, guys? Any question? Is it clear to everyone? Raise your hand. Let me see if you are following clearly. All right, Ms. Cabrera. Ms. Green, how about you? Ms. Dorothy? Ms. Waysome?
Sir, can go over the last part, please?
All right, from where I do the solution?
Yes, sir.
All right. Ms. Waysome, are you following? It seems like Ms. Waysome is busy. All right, so Ms. Green, once we have found the inverse of these functions, so we are given the function f of x equal to 4x plus 5 over x plus 2. So in order to solve this equation, if you notice that this equation, the fraction, which is the function, is basically the same as what we have in this equation. So we have 4x plus 5 over x minus x plus 2. So because this is equated to a value, which is 3, now remember now, this would be the domain of f of x. So this, the x value would be the domain of f of x. So when you put a value here in x and you calculate, you will get 3 as your answer. So this 3 that you get as your answer here is actually a y value. Now, if you're solving this function equal to a y value, all we need to do is to find the inverse of that function, which we did, and then you use this y value as the x value for the inverse function. So you use the 3 as the x value that you're plugging into the inverse function. And once you do that calculation, then whatever you get as your solution would be the answer to x. All right, so what we did here was to plug in 3 in the inverse function where x is. And so wherever x is, we replace it with 3 on the right-hand side. Then we do our calculation on this right-hand side. So we have -2 times 3. Remember the order of operation, you do multiplication first. So you multiply -2 by 3, you will get -6. All right, so in the numerator, you'll have -6 plus 5. Now in the denominator, we have, remember we replace this x with 3. So this is +3 minus 4. Now if you're adding a negative and a positive number, you take away the numerically smaller one from the larger one and keep the sign of the larger one. So you take away 3 from 4, you get 1, you keep the sign of 4, so you get -1 in the denominator. Same thing you do for the numerator here. The numerically larger number is 6, but you're taking away 5 from 6 and keep the sign of the 6. So 5 from 6 give you 1. So you get -1 in the numerator over -1 in the denominator. And if you divide a -1 by a -1, you get a +1. So the solution for x is 1. That means x is equal to 1. Is that clear now, Miss Green?
Yes, sir.
All right. Is that clear for everybody? Raise your hand for me, please. All right, moving along. Ms. Waysam, are you there? Can you at least indicate so that I know that you're there? Ms. Waysam? Oh, okay, I'm sorry to hear about that, Ms. Waysam. All right, so moving on. So this is what we have done. So we find the inverse of the function, rewrite f of x with y equal to 4x plus 5 over x plus 2, interchange x with y. So we have x equal to 4y plus 5 over y plus 2. Then we transpose, and so we will get y equal to 5 minus 2x over x minus 4. So when we will get our inverse function to be this. Now, don't be too concerned about how the expression is arranged on the right-hand side. You just only want to know that the correct values are on the right-hand side. So now, to solve our equation, we plug in the value of 3 in the inverse function where x is, do our calculation, and we get the value of x is equal to 1. All right. Now we're moving on, and we're going to be looking at what we call composite function, which is a function of a function. Is anybody familiar with a function of a function? Raise your hand if you have done this before. All right. Now, generally for composite functions, what we're really doing, we are merging two functions together to make a new function, right? And that's why we call it composite function. Now, we can go two ways when we are doing our composite function. One way, so if we look up here, this would be the function defined by f, and this would be the function defined by g. So we have two separate functions, but we want to make the two of them, merge them into one function. So a composite function would be now putting in the function f into the function g. Now, what that means? It means now that we are treating the entire function of f. Let me give you a sense of what is happening. So this, what we have for the function f. So f of x equal to 2x minus 1. This is the function g. G of x is equal to 3x plus 2. Now, when we find g f of x or g of f, what we are doing, we are putting in the function f into the function g. Now, how do we do that? Now, it is similar to substitution. So if we were to substitute a number for x here, then